This video is for Chapter 6, Section 5. It's all about trapezoids and kites, and more specifically isosceles trapezoids, and the properties that we'll find. Let's get started. First, we're going to start with trapezoids. Now, we want to get to isosceles trapezoids, but trapezoids themselves have a few properties or a few things that we should make note of. One, the idea of a trapezoid is that it has one pair of parallel lines. So two parallel lines, that's it. Right here, there's a pair of parallel lines. The other two lines are not parallel. What we have to do is go back to what we know about parallel lines. These lines are transversals, causing X and Y to be same side interior angles, W and Z to be same side interior angles. So this is important to us because we remember that same side interior angles are supplementary when the lines are parallel. X and Y add up to 180, W and Z add up to 180. We don't know anything about X and W or Y and Z. Instead, we have two pairs of same side interior angles that are supplementary. So this property for trapezoids is important for us to remember. It has two pairs of supplementary angles between the parallel lines. We have to look between the parallel lines and see X and Y, W and Z as pairs of supplementary angles. And we can use this to find missing angles within a trapezoid. Okay, so that's it for trapezoid. We're going to go to the isosceles trapezoid, which is has a little more uniqueness to it. What I'm going to start off with is an isosceles triangle. This is where we know the word isosceles from. This triangle right here has two congruent sides here and here. We know those are the congruent sides because they are opposite those congruent angles. Now, what I want to do is imagine that I could grab onto these two sides and start pulling the triangle apart. And it's going to come apart at the vertex. And that vertex I'm then going to connect with a horizontal line parallel to this base. And it's going to look something like this. Now try to imagine, there was that isosceles triangle. These are the exact same two legs. These are the exact same two angles. I haven't changed anything. All I've done is I've pulled it apart. And now I have an isosceles trapezoid. So these are still the legs, and these are called base angles. Now, up here, these are also called base angles, and it's very important that you stop at some point and mark those congruent as well. Because the major property is base angles of an isosceles trapezoid are congruent. Now, we see these two as being the isosceles triangle. But remember, if this was 80, this would be 100 from our previous slide. And if this is 80, this is 100. So take the time right now to mark that when I say base angles of an isosceles trapezoid are congruent, I'm talking about these and these. Now remember, base angles are congruent only if the trapezoid is isosceles first. Now, there's one more property for trapezoids. I'm going to draw some diagonals in. Here I have isosceles trapezoid ABCD, same as this one, but I've drawn some diagonals. This caused a lot of triangles, and it makes it hard for me to see the triangle I want. So I'm going to separate them. I'm looking at triangle ABD and triangle DCA. I already know that AB is congruent to CD. That's the isosceles trapezoid part. And I know that AD is congruent to itself, the reflexive property. From this statement, the base angles are congruent. BAD is congruent to CDA, that angle right there, CDA, over here. Through this chapter, we've been using congruent triangles to show these properties of quadrilaterals. Here again, we have triangles that are congruent by side angle side, which means the third side, BD, and CA must be congruent to each other because they're corresponding parts. So the triangles are congruent by side angle side. Therefore, we have come up with our second property. Diagonals of an isosceles trapezoid are congruent. Now, this is a very interesting property because the diagonals of a rectangle are also congruent. So how are we going to know the difference? When we have congruent diagonals, how are we going to know the difference? Well, this picture shows diagonals that are congruent. See, if this was 5, that would be 5. If this was 8, this would be 8. 5 and 8 make 13. 5 and 8 make 13. This shows congruent diagonals. But one really important thing, they're not bisecting each other. 1, 2, 1, 2. If they are congruent and not bisecting and make isosceles triangles, see, there's an isosceles triangle here and here. That is enough for it to be an isosceles trapezoid. So we need to be very careful here. If we have a rectangle, they will be congruent and bisect. If we have an isosceles trapezoid, they will be congruent, but they won't bisect, and they will create isosceles triangles. That's your then hint. Congruent but not bisecting, but still has isosceles triangles. That is what will make an isosceles trapezoid. That's it for trapezoids as a whole. Now we're going to move on to kites. And kites are a little bit crazy. Here's our kite. 2 pairs of congruent sides. And what I'm going to do is I'm going to draw a diagonal from here to here, splitting the congruent sides. So split these 2 congruent sides, split these 2. And that diagonal, if you mark it congruent to itself, clearly makes 2 congruent triangles. So this is kind of like a line that we can fold the shape on. And that's called a line of symmetry. So my first property for kites is that the diagonal that splits the congruent sides is a line of symmetry. And to me, it means it bisects everything it touches. It bisects these angles and they are congruent. You need to add these markings to your pictures. I cannot due to what I'm going to show as the slide moves on. These angles are congruent. These angles are congruent. They're being bisected. The triangles are congruent, so this angle is congruent to that angle. Absolutely critical to solving the angles of a triangle. These 2 are getting cut in half, and these 2 are exactly the same. So, if it bisects everything, let's throw the other diagonal on, and we have to recognize it's cutting this diagonal as well. Now, short, long. The first diagonal is not being bisected. Only the second one is. And it's causing a bunch of congruent triangles in here. So, because of those congruent triangles formed by the diagonals, all 4 of these angles have to be exactly the same. That's the same as this one's vertical to this one's the same as this one. And when we have 4 angles all exactly the same, 360 divided by 4 equals 90. These are right angles. And so now our conclusion is the diagonals of a kite are perpendicular. You should be marking the right angle box into this picture now for all 4 of these angles. Keep in mind, the diagonals of a rhombus are also perpendicular, so just having perpendicular diagonals is not enough for us to decide what shape it is. Rather, we are looking at it from, if it's a rhombus, diagonals are perpendicular. If it's a kite, diagonals are perpendicular. Okay, the last thing I want to do before this video is done is make sure you understand the markings that should be in this picture. So I will not be marking them up, but you will be adding them to yours. 4 right angles right here. 2 congruent angles here because they have been bisected. Double angle mark here for 2 more congruent angles. And lastly, this big angle is congruent to this big angle, but these 2 are not. Somehow if you can mark that for yourself, that the big angle is congruent to the big angle, but these little ones are not. Rather, they are congruent across from each other. Everything on this side is the same as that side. That's what symmetry is. That's it for Chapter 6, Section 5, Trapezoids and Kites. You can now begin the assignment.